Okay, let's talk about how you solve equations that involve trigonometric functions. Now, sometimes we want the solutions in degrees, sometimes we want them in radians. When we don't specify, unless we say otherwise, you should give your solutions in radians. So if the equation that we're trying to solve is cosine of x equals -1, well, x could be 180 degrees, or x could be pi radians. Do we want exact solutions or decimal approximations? For example, pi would be the exact solution to this equation. 3.14, which is only approximately equal to pi, would be a decimal approximation. Unless we say otherwise, we do want exact solutions. A decimal approximation is not good enough. And sometimes we just want a solution, just any one number that works. Sometimes we want all primary solutions, that is, once around the unit circle, and sometimes we want all possible solutions, a complete description of anything that works in the equation. So unless we say otherwise, that's what we're looking for, a description of all possible solutions to the equation. Now, let me walk you through some examples. So we're going to solve the equation 2 cosine x plus the square root of 3 equals 0. Step 1 is to isolate the trigonometric function. Get it so that the cosine of x is by itself on one side of the equation. So we get cosine x equals negative square root of 3 over 2. Now we have to figure out what x can be so that the cosine of x is negative square root of 3 over 2. And unless you really remember your cosines, it can be helpful to look at the unit circle. Remember, the cosine of an angle or a number of radians is the x-coordinate of the point on the unit circle. So where is the x-coordinate equal to negative square root of 3 over 2? Here's one place, 5 pi over 6. And here's another place, 7 pi over 6. And those are the only two possibilities, one in quadrant 2 and one in quadrant 3, where cosine is negative. So cosine of x equals negative square root of 3 over 2 when x is 5 pi over 6 or 7 pi over 6. So those are the only possibilities between 0 and 2 pi, once around the unit circle. But once you found one possibility, you can add or subtract any multiple of 2 pi to take you all the way around back to that same position on the circle and get another possibility, another number of radians whose cosine is negative square root of 3 over 2. So all solutions would be 5 pi over 6 plus any integer multiple of 2 pi, or 7 pi over 6 plus any integer multiple of 2 pi. So here's how we can write that. X equals 5 pi over 6 plus 2 n pi, and 7 pi over 6 plus 2 n pi, where n is any integer. Okay, I'm not going to go over all the details of all these examples. You can look over them on your own, but I am going to point out in this one, there are two terms that have a common factor of cosine x. So we start by factoring that out, and then we use the old algebra trick of if there are two things multiplied together equal to 0, we can set each one individually equal to 0. So for cosine of x to equal 0, look for where the x-coordinate of the point on the unit circle is 0. That happens at pi over 2 and at 3 pi over 2. For sine of x to equal negative 1/2, the sine is the y-coordinate of the point on the unit circle, and that's negative 1/2 at 7 pi over 6 and at 11 pi over 6. And to get all possible solutions, we take those and add on any integer multiple of 2 pi. The secant of x is the reciprocal of the cosine of x. So if we want secant x to be 2 over the square root of 3, that means cosine of x has to be the square root of 3 over 2. To find where the tangent of x equals -1, remember the tangent is the sine over the cosine, or the y over the x. If we're looking for where y over x equals -1, that means the y and the x have to be the same absolute value, but one's positive and one's negative. Where does that happen? Well, right here at 3 pi over 4, and also down here at 7 pi over 4. Tangent is negative in quadrants 2 and 4. So the solutions are 3 pi over 4 plus any integer multiple of 2 pi, and 7 pi over 4 plus any integer multiple of 2 pi. And in this case, it's possible to combine these into just 3 pi over 4 plus n pi, because if n is an odd number, if we add just pi or 3 pi or something like that, we get something equivalent to 7 pi over 4. Example number 4, notice this one is asking just for solutions in the interval between 0 and 2 pi. And this involves both the cosine of x and the secant of x, which is 1 over the cosine of x. When I write it that way, we have an equation that involves fractions. I start by clearing the fractions by multiplying both sides by the denominator of this fraction. And that gives me 2 times the cosine of x squared plus 1 minus 3 times the cosine of x equals 0. Now, since this involves the cosine of x squared and also the cosine of x, it's like a quadratic equation where the variable is cosine of x. If we wanted to make it really look like a quadratic equation, we could substitute in and let u stand for the cosine of x. And then it would be 2u squared plus 1 minus 3u equals 0. So if you go ahead and solve that quadratic equation, it turns out that u is equal to either 1/2 or 1. But remember, u is really the cosine of x in disguise. So cosine of x equals 1/2 or cosine of x equals 1. Now go back to the unit circle and find what x can be so that the cosine, the x coordinate of the point on the unit circle, is 1/2, and find the point on the unit circle where the x coordinate is 1. So the possible angles or numbers of radians are pi over 3 and 5 pi over 3 and 0. Example 5. Now here, when we isolate the trigonometric function, we get that the sine of 3x equals -1/2. So here, the thing that we're taking the sine of isn't just x, it's 3x. So it's 3x that can equal 7 pi over 6 plus any integer multiple of 2 pi, or 11 pi over 6 plus any integer multiple of 2 pi. And then dividing both sides by 3, we get that x equals, notice we've divided by 3, so 7 pi over 18 plus 2/3 in pi, or 11 pi over 18 plus 2/3 in pi. Example number 6, 2 sine x cosine x equals 0. I can divide both sides by 2, and then again, that 0 factor property, two things multiplied together equals 0, so one of them equals 0 or the other one equals 0, and we get our possibilities for x. Example number 7, 4 times the secant of x equals 3, divide both sides by 4, secant x equals 3 over 4, so the reciprocal cosine of x equals 4 over 3, but that's impossible. The cosine always gives us a value that's between -1 and 1, so it can never be 4/3 because that's greater than 1. So this has no solutions because cosine of x always has to be less than or equal to negative or less than or equal to 1. It can never be equal to a number like 4/3 that's greater than 1. And example number 8, find all solutions in the interval from 0 to 2 pi. Well, isolate the trigonometric function, which is cosecant of x. The reciprocal of that is sine of x. So for cosecant to equal 2, sine has to equal 1/2. And so the possibilities for x in the interval from 0 to 2 pi, once around the unit circle, are pi over 6 and 5 pi over 6. You usually do get two possibilities on the unit circle. So it helps to keep in mind which two quadrants to look at. Like here, we're looking for where the sine of x is positive, which happens, well, sine is positive in quadrants 1 and 2. So those are where we found these two angles. I've got some different kinds of examples involving finding approximate solutions with the help of a graphing utility, and I will show you how to do those in a separate video.